everyone. Thanks for coming. This, I know, was a long conference, so thanks for still attending this last slot and coming to this presentation. My name is Dockter. I'm the founder of Gradle and the CEO of Gradle Inc. And I want to talk today about developer productivity and developer productivity engineering and what we mean with that practice and why it is important. So we've been in the trenches with all kinds of organizations for the last 10 years, right? From the Wall Street banks to the Silicon Valley giants and everything in between, small, medium, large development teams. And what we have clearly seen is that toolchain effectiveness is a major bottleneck when it comes to developer productivity. And one important part of toolchain effectiveness is the speed. How long does it take for you to get a response from the toolchain? If you think about it, right? So I kind of like that analogy. So a scientist, right, needs to be very creative, right, in a very scientific way, right? So a scientist has a hypothesis and then enters a dialogue with nature to do an experiment, right? Via an experiment, and then nature answers, and based on the answer, the hypothesis is validated or needs to be modified. We do something similar. We have a hypothesis, which is our latest code, and then we enter a dialogue with the toolchain. Hey, compiler, what do you think about that hypothesis, right? Hey, check style. Hey, integration test. Hey, unit test. Or you want to do manual testing, so you have to run your hypothesis to see how is it behaving, right? And the health of that dialogue, right, is determined by how long do you have to wait for a response and how reliable is the response. For example, it's not that reliable when you have a lot of flaky tests, right? And that causes a lot of problems, right? But a very, very important part of the health of the dialogue is the speed. So, and that is a very interesting topic because everyone agrees here. I don't think there is a single person in a room that would say, slower builds and tests are better than faster builds and tests. But the question is, I hope, right? But the question is, right, how important is it? And so one important part of the feedback cycle time is how it affects the creative flow. And what I want to show you is data, is real world data. This is very famous software organization. Probably most of you use their products. And we measured a team with 11 developers and a team with 6 developers. And a team with 11 developers had a build time of 4 minutes. 4 minutes doesn't sound terrible, right? So most people think when they have 4-minute build time, it's not an issue build time, right? Then another team with 1-minute build time. So what can you see, right? The number of times the developers ask for feedback in a small team is twice as high per head, per developer. And you can already see, although no one in team 1 might be complaining about the 4 minutes, it's changing their behavior. They're asking less frequently for feedback, right? Maybe working on bigger change sets before they commit something. You can already see there is a tax involved with the 4 minutes, right? So it really affects the way how people work. So even build times that look harmless have already a negative effect, right? And then obviously there's another big effect. It's not just my creative flow, right, that is affected by that. It's pure waiting time that is induced by this. So there are various studies around that. When a developer waits for something that takes less than 10 minutes, then they very often don't do any context switching. And it's pretty obvious. Let's say we wait for something that is 15 seconds, right? What can you do in 15 seconds? You just wait, right? And then there's the boundary where behavior slowly changes, where some people start to do context switching, but under 10 minutes, a significant amount of the time that the toolchain requires to give you a response is waiting time. So this team with 6 developers, right, is running 1,000 builds a week, and their build time is 1 minute. I would say for many people, that's a dream world, right? 1 minute build and test time, right? So why should we do something about it? Well, we got the build time down, working with them, to 0.6 minutes. And that means 44 days of saved, annihilated waiting time. So they have now 44 days more engineering capacity. And that is for me, that's one of my key messages here. When you ask a team with 1 minute build time, should we do something about it? They probably said, well, we have more important thing to do. But people assess this just by their gut feeling. But once you look at the data, hold on, you're running this 1,000 times a week, the equation changes. Now you see, hold on, investing into that, right? Maybe if we invest a week of engineering effort into getting the build to 0.6 minutes, we get 44 days back. This sounds like a really good deal, right? And without having this data, you cannot make that call. And let me ask you a question, and I don't expect many hands, if any. Who of you knows how many times people run their builds locally on their machine in your organization? Right? No one knows that. How much time do they spend waiting for tests, right? How much time, I could get more sophisticated, how much time are they spent for waiting for annotation processor X to finish, right? Where we could go very deep, right? And almost no organization even has the most basic data about that. And then it's hard to make a call, right? Should you prioritize that or should you not prioritize that? So we collaborate closely with the Google Android team, and they're doing surveys around what the Android developers kind of what is most important to them, right? And what are their biggest challenges? And performance is a very important topic in the Android world. So together we invested a lot of our resources to make Android builds faster. But for some of those, developers had to restructure their code. And then they say the biggest challenge is to convince management to get resources for doing that instead of doing feature A. And the problem is they don't have the data to make a good business case, right? So if you talk with organizations, right, or if you look at organizations that have, like the other team 3, 100 developers, 12,000 builds per week, you get the build time down from 9 minutes to 5 minutes. Now we're talking about 5,200 days saved in waiting time. That's 25% of the R&D capacity, right? And to be honest, I'm a little bit frustrated when I talk with some organizations, right? They have an interesting approach towards that. When I ask them, well, what if we could get the build time down from 9 minutes to 5 minutes? They say, well, performance is not a problem. I say, what does it mean it's not a problem, right? You can save 5,200 days. Well, but it's not a problem. Aha, not a problem means no one is complaining about it. So it's completely reactive. If no one's complaining about it, great, right? And if people are complaining about it, then the person who complains the loudest gets what they want. So we're in a pretty immature state, right? It's just a reality. As a software industry, when it comes to understanding where we should invest and not invest into developer productivity, right? So, okay. But there is an easy solution to that problem, right? To reduce waiting time. Just make your builds and test take longer than 10 minutes, right? Then people do context switching. That is what you should take home from this conference. Have one thing you should take home from the conference: make your builds and tests take longer than 10 minutes. Of course, I'm joking, right? So we have organizations with build times, 5 minutes, 10 minutes, up to an hour, multiple hour. The most extreme I've seen was a C++ team, 24-hour build time, right? A big mono repo. So, of course, when you have 24-hour build times, I hope you're not waiting for the build to finish, right? So people do context switching. And context switching is an interesting one, right? So let's say you finish your feature, you commit your changes, and then pull request is running, auto merging. If everything is successful, the build time is not so much of an issue, right? On a happy path, everything is green, fire and forget, right? But whenever the build fails, you switch to one thing, you have to switch back, right? And context switching is expensive, right? That's why people don't do context switching. They know when it's 5 minutes, it takes too much of a toll, right, to start a next task. So whenever you have a failing build or whenever you need intermediate feedback to continue with your work, right, then this is a high cost, right? And the measurements we are doing, right, and although there is a big range, in average, 20% of all CI builds are failing, right? That's an average number we're seeing. And it's good because hopefully you have good test coverage, right? And we detect a lot of problem via this, right? But you still need to do context switching and understand what's going on. And an unreliable tool chain substantially increases this cost. Because when I talk with people, what is your average build time, right? Let's say they say 5 minutes, right? Yes, that's the average build time when you're on a happy path. But the actual average build time is the average build time it takes to have a successful build, plus things like percentage of flaky test times build time, plus debugging the flaky test problem. That is your average build time, right? The time really it takes you to get a clean pull request build, right? So performance and reliability are closely related in that way. So, and another thing we're seeing everywhere, when you have let's say a 20-minute build time, right? What you know, and plus flaky tests, you know, every pull request build is a pain in the neck. To get everything green and mergeable is a pain in the neck, right? So what behavior does change? What happens to the size of your change set? It increases. Because you know it's a high text to get anything through. So I speculate that will be the happy path, and I try to get as much stuff as possible into my pull request, right? But then when it fails, I now have a large change set, and it's much harder to understand why, what is the root cause for that problem, right? So, okay, and in general, right, there's good research around, there's an exponential relationship between the time it takes to detect the defect and the time it takes to fix the defect, right? And that is related to some of the stuff I've already mentioned. So now I want to share an interesting story, right? So who of you here has build and test times in some repositories longer than 10 minutes, right? So everyone else, every repository, including test run, who has build times, who has not a single repository that takes longer than a minute to build and to test? Okay, so most are here, I guess, between 5 and 10 minutes. Okay, so we were working with this organization. They're having a large Maven mono repo build, and their build time was 25 to 30 minutes, including testing. And the developers were starting, understandably, to complain. Hey, we cannot work like this, where we cannot do a change and then always have to wait 30 minutes, right, for the local build and then commit our stuff. So that got escalated, the VP got involved, they established a task force, and that task force then did a good job. They got the build time down from 25, 30 minutes to 20, 25 minutes. That was not enough, right? Their idea was a build time, faster than 5 minutes. So they did a magic trick, the task force, right? They said, you know how we get the build time lower than 5 minutes? Stop running the tests. And I mean, with a straight face, they told me, we solved the problem. A straight face. I said, okay, well, yeah, you probably. So, but then you have the situation now, you don't have a local quality gate anymore that is of value. So you're now doing the opposite of continuous integration, right? You're integrating later, right, via some pull request build, and you're asking much less for feedback. So now you're shifting basically this whole exponential curve even more to the right, right? And that we talked about, it's just creating one pain point after the other, right? That increases likelihood of merge conflicts and the whole nightmares, right, of doing software development in larger teams with long-running builds, you know, will kick in. And then you want to do agile, right? Yeah, have fun doing agile in such an environment, right? So, okay, so, but even the important thing is to understand for build time, better is better, right? Even if you have a 1 minute build, you can get it down to half a minute, you know, usually it's worth it, right? And yeah, if you have a build that is 30 minutes, everyone understands that something needs to be done. But please do not stop running the tests, right? So, but what can you do? What can they do, right? They have this build, they have this Maven monorepo. They could now say, let's try to break it into pieces, you know, let's have smaller repositories. But you get other complexity with that because there are still the dependencies between the repositories. You have to make you have to make the thing faster. That is what you have to do. And a key technology for that is build caching, right? So that is, for me, it's almost like, I remember when I put an SSD drive in my old MacBook and it was like I had a new machine, right? That is kind of what a build cache is doing for your, let's say, for your Maven builds, or also for the Gradle build, obviously, right? For any build. So let's take, who of you here is using Maven? Who of you is using Gradle? No, it's 50-50. Cool, so yeah, both sides are represented here, right? So on the left, you see a simple Maven multi-module build. On the right, a Gradle multi-module build. So the idea of build caching is simple. When the inputs have not changed of a Gradle task or a Maven goal, reuse the output from a previous build. What could be simpler than that, right? To give an example, right? So when you build this project with, let's say, with Maven, right? You always run Maven clean package, something like that, right? But also with Gradle, you probably run Gradle clean test on CI, right? So when you run a clean build, it means whatever your change was, you have to run 5 times compile, 5 times check style, 5 times compile test, 5 times test, and any custom goal like generate sources. So with a build cache, that completely changes. So let's say you change a public method, right? You do some change in the sources of the export API module. And now you're using a build cache. So what the build cache is doing is the following. The build cache hashes the inputs of every goal or every task. So let's say for the compile task, it hashes the source files, the JDK version, the class path, the compiler arguments, and out of those hashes, it creates a key that uniquely represents that input, right? But it's not just for compile, right? For test, it's the same thing. The inputs are the test source file, the runtime class path, the Java version. So build cache creates a key from that, right? And then stores the build output from that goal under that key in a cache. So, and then when we run the build again, and we only changed export API, and let's say no other module depends on export API, then when let's say the compile goal of the core module is about to be executed, right? We analyze the hashes, we calculate the cache key, we ask the build cache, do you have output? And the build cache says, yes, I have it from before, right? So don't run the goal, get the output from the cache, right? When you compile the export API module, right, we calculate the hashes, create the key, we ask the build cache, do you have output for that input? And the build cache says no. Then we run the compile goal and we publish the output in the cache, right? So, and of course, if you have dependencies between the modules, which you usually have, right, that also is very efficient, right? Let's say the web let's say web app depends on security, and you're running Maven clean package, and the only thing you're changing is the security module. Then you have to recompile the security module, you have to rerun check style. The build cache is smart because you only change the implementation detail of a method. We don't need to recompile the test. We need to rerun the tests for security because the implementation has changed. For web app, we don't need to recompile even web app because we only changed the implementation detail of security. We only need to rerun the test of web app. So instead of executing 25 goals, including 5 test tasks, you only run 4 out of 25 goals, right? And the benefit of that is significant, right? So this is a real-world example. So Spring Boot is using, well, they just migrated to Gradle, but until 2 weeks ago, they were using Maven, and their Maven build took 20 minutes to compile and run a unit test. They have 300,000 lines of code, 100 submodule Maven build, and fully cached. You get this time down to under 2 minutes, right? And fully, of course, a build is usually never fully cached, right? You change something, right? But the reality is, do I have? No, I don't have it here. The reality is when you at least, as your number of modules are growing, what we're seeing that often 50% of your submodules are leaf modules. No other module depend on that leaf module. So when you change a leaf module, your build time is reduced by, to 1 divided by number of modules, right? So if every module takes a minute and you change a leaf module, from the 100-minute build time will go down to 1 minute, plus some overhead for the caching, right? So this is extremely powerful. And we are using this technology. LinkedIn is using that, Airbnb, right? Cisco, right? This is proven technology, and the impact we're seeing everywhere is very significant, right? I would expect for any non-trivial Maven build that you get at least 50% build and test time improvement. Plus, who of you here is an architect, kind of is involved with architecture decisions? So one thing you're probably promoting is reducing the surface area of the modules, better modularization, right? You now have another argument for that. It's not just for the maintainability of your code base. The better your code base is modularized, right? Let's say each of those modules, let's say this would be a big project which is not well modularized. Let's say every module has 50,000 lines of code. Let's say, right? Now you have a reason to say, hey, if we get 10 modules out of that with 25,000 each, we not just have a better modularization, we also have more incrementality in the build because the cache is basically a form of incremental builds, right? And it's funny. I'm curious who is in that situation as an organization. Well, I shouldn't say necessarily it's funny, but it's kind of fun. So you have all those organizations. They have their big monolith, right? And when we talk with them, I always have my usual questions. How is your code organized? Is the code in one repository? Do we have many repositories? And then there was this one organization that said, oh, we have hundreds of repositories, right? Hundreds. Yeah, okay. And I said, is the code evenly distributed amongst those? No. 90% of the code is in one repository, right? It was a 400 submodule Maven build. Now the best thing is, and within that repository, how is the code distributed? Well, one of the 400 submodules alone had 1.4 million lines of code. So yes, they're going microservices, they're trying to walk into a better future, but they still have the majority of their code is in a monolith. And that's what we're seeing a lot out there. So I'm curious, when the people said our build time is 1 minute, is that just, do you still have another team that has to deal with the monolith? Because that's what we're seeing very often. The microservice people say, we are fine, right? But it's only a small percentage of the code base. And what I tell everyone is, don't break your repositories apart just because to make the builds and tests faster. There is better technology for that, right? Try to break them apart according to organizational boundaries and release flexibility, right? And then look at acceleration technology for the build to make all of those fast, right? And what I also strongly recommend, right, is when you have a monolith, right? Even, yes, you hate it and you want to live in a microservices world, but you have that monolith, right? And you cannot ignore the build time for that monolith, because wherever you want to go, whether you want to stay with the monolith, whether you want to get rid of that over the next 2 years, when you don't make building and testing the monolith fast, wherever you want to go, you will be slow. Because breaking a monolith into pieces requires a lot of refactoring, a lot of pull request build, a lot of changes in the monolith. If that takes a long time, breaking it into pieces takes a long time. So invest into, don't ignore it because you hate it, right? You have to embrace the reality that if you really want to get rid of it, you have to be able to work effectively with it. And then you can also make decisions not just based on, oh, it takes so long to build that monolith, right? Because we can make it fast. Okay, so another nice aspect of build caching is it takes a lot of load from CI in terms of compute resources. So this is a real graphic from a company with 150 engineers, and they're measuring how many CI builds have to wait for an agent to be available, right? And you could see before they introduced build caching, it was 40 to 50% of the CI builds had to wait for an agent. I don't have the number how long they had to wait, but they had to wait. And then introducing the build cache, right, and optimizing it, the first time, for a long time, they had a day when there was no queue, right? And of course, you can always solve that problem with more agents, but yeah, we have 200 CI agents, that's a sizable cost that we're paying for that. So everything that brings that cost down is much appreciated. Okay, yeah, I talked already about that. Okay, so let's skip those slides. So the other thing we are working on, right, is distributed test execution, so that you make it easy for developers to have local builds with super fast test execution, and that you can shell out test execution to as many agents as you want, right? And the distribution granularity would be per test class. Okay, so this is acceleration technology, but we already talked at the beginning of my talk about the data, how essential it is to have the data. So one of my favorite questions is, it's the opposite of that question. I will talk about that later. So my favorite question is, let's say you're somehow responsible for builds and tests, right? Or you just do it because you care and you want to make them faster. Let's say the code base at your organization is growing by 30% next year, and you make your builds and tests faster by 10%. Who would notice? Who has a company that would give you an award? Most companies wouldn't notice, right? But if we look at the numbers, let's say you're a 100 people engineering organization, we're talking about a saving of $100,000s, maybe millions of dollars, and the equivalent of additional R&D capacity. And yet that would be under the radar. That should not be the case, right? On the flip side, when the build gets slowly slower and slower, who notices a small regression? Who is at an organization where, let's say, a developer is introducing a new annotation processor, and that annotation processor is increasing compile time by 15%? Who would notice that? Probably no one, because there's so much fluctuation in the build time, right? So you have regression after regression after regression. Then you might, in a hack week, you get so desperate that you do some improvements, right? And then you have the regressions again, right? So no one notices them. So let's say you're a developer and you're running a local build from wherever you're working from, and 3 or 4 times a week it behaves weird. Let's say it's really slow. What do you do with that, right? Do people report that usually? My experience is they don't report it for 2 reasons, right? Because if they do it, and then someone who is responsible for the build helps with fixing it, it means, oh my God, half of my day is gone on working with the person who's trying to fix it, right? So, and the other problem is, if I'm the person who is doing support for builds and whatnot, how should I now prioritize that, right? First of all, I'm wondering, can I even trust that guy? Is that guy fantasizing, right, about that, right? And maybe he's the only person or she's the only person in an organization. I have other stuff to do, right? So, so it's hard for me to prioritize that as a support person because I don't know, are you the only one who's suffering from that? Are there more people? And number three, it's a problem with the local build. It's so hard to understand the root cause, right? So that's why this stuff often gets ignored because it's just too hard to deal with it, right? So, and that's why we're saying you have to capture comprehensive data of every build and test run. It makes so much sense, right? That's our assembly line, right? And every other industry is capturing this data. We in software don't do that, right? And when you don't have comprehensive data and you have such a flaky problem, right? You have to spend a lot of time to reproduce the problem. But when you have comprehensive data about each and every build run, we could, for example, see there is a problem with the Artifactory proxy in the location of that person. It happens once we have the data. Without the data, we don't do anything and people surrender to it. And we have now a culture that people consider builds as unreliable. They are probably the most cursed tool in the organization, right? And we accept that they have low quality. But a key reason for that is we don't have the data to improve them, right? So, and the way I look at it, right, let's say you have a chemical factory, right? You have a vessel and you're selling the liquid that is produced in that vessel, right? Show me a chemical factory that doesn't have two things, right? One is high-level metrics. What is our output of liquid per hour, right? And when that drops, the red alert goes on. That's the first thing, right? But then, what is the root cause for that drop? So they know the pressure in the vessel, the temperature, the concentration of the chemicals, so that they have the data, right, to understand what is going on. What are we doing, if you think about it, what are we doing in software development when we have a weird phenomenon, right? The equivalent, what we're doing in software is usually, let's throw the vessel away. Let's empty everything out, let's refill it, and let's see if that fixes the problem. We call that rerunning the build and the tests, right? That's our usual behavior pattern, right? So another reason why it's so important to have the data about every build and test run is the following. I want to share an interesting story. So we were talking with an organization that wanted to accelerate their build and test time, and they wanted to try out build caching, right? So we have a product that provides a build cache, right, called Gradle Enterprise for Maven and for Gradle, and they were super excited, and they created two branches, right? Sorry, they created an additional branch. Their normal branch was with their normal build, the way they're building, they have been building, and then another branch, the same code, they just added the changes to connect that build with the build cache, right? And then they called us and said, the build with the build cache is 5 times slower than the other build. That's not what we wanted to hear. We thought we have a high 6-figure deal here, and then they're telling us everything is 5 times slower. So we were like, that cannot be. Something must be different between the two branches. And they were saying, no, the builds are run exactly the same way, 100%. And those were the build experts, right? So now, if you don't have any data, you have to trust them. We were getting to a point that they were annoyed by us questioning them. So we thought we have to fly someone in, but we collected some data, and then we saw something interesting. The build without the build cache, 128 threads. The build with the build cache, 1 thread. So how could they not see that? It was an interesting, and it's. I want to share the details, right? So they had a parent directory with a .nvm directory that had a Maven config file that said, use 16 cores. But for connecting our builds with the build cache, they also had to create a .nvm directory with some Maven extensions. And the behavior of Maven is it only looks for the closest .nvm file. It looks, when it finds one, it doesn't look in the parent directory. So the build with the build cache never reached the .nvm directory where it says 16 cores. And the gist of the story is those were the build experts. And yet, builds are so complicated. When you rely on interpretation of what has happened, that's hard, right? And when you need to help someone with the build and test issue, and you ask them, what version of Java are you using, right? And they tell you, oh, Java 8, right? Who knows? Might be Java 11, right? They might think they use Java 8, right? So you need to have the data to see what actually happened. Otherwise, you cannot effectively troubleshoot, right? So, yeah, that's that was at one point one of our engineers. We also had some struggles with reliable pull request builds. So for me, and from a maturity point of view, right? We had an organization, right, that they had the following incident. Their infrastructure team was changing the Docker configuration for the CI agents. And that has caused quite a number of CI builds to fail. So let's say that happens at your organization, right? So what would the normal workflow be? So someone introduces something that now leads a significant number of CI builds to fail. Here's what I think is the process at your organization. Please correct me if I'm wrong. The first developer who runs into that error goes to the Jenkins job page, looks at the console log, is seeing a weird error and saying, let's run it again. Let's wait for another 10 minutes, 15 minutes, 5 minutes, whatever. Runs it again. Maybe runs it one more time. At one point, the person will say, okay, CI team or whoever is responsible, I have no idea what is going on there. The CI team, the support team will say, I will look at it later, right? I will look at it later. Okay. Next developer running into that, doing the same dance. At one point, the CI support team might think, oh, it's now 4 people with the same problem. We might have a problem here. We might need to prioritize that. Or maybe the VP is giving that person a call, right? But you see the immaturity of that. It's completely reactive. There's a problem. If you had the data, you could easily identify that, right? You just need to analyze your failure stack traces and see, oh, there's a new, yep, please.
So that's not really how it would go, because we'd look at the previous version from here. Does that still build green? If yes, then you did it, go figure it out locally. And if no, then we are where you say we are.
Okay, good. But then you still need to decide how do you prioritize that problem? Is that a one of a time? Is now everyone affected by that? And that's already a good practice that you're having. Not every organization is doing it like this. Yeah. So, and again, you want to analyze all the stack traces. You want to proactively see there is this new type of failure, right? And I do proactively something about this, right? You don't want to be reactive. It's, for me, developer productivity engineering is a maturity model, right? And a big thing is, big part of that is moving from reactive to proactive. Yeah, who of you here is affected by flaky tests? Yeah, one hand was going up. It's a very emotional topic, right? So what are you doing about that? How are you trying to fix that? So how do you detect a flaky test?
Because at one time the Jenkins test passes, and the second time it just breaks.
Yes.
And we have like, okay, bad, and at some point someone says, hey, I think we have a flaky test.
Cool. So my question here, I didn't see many hands when it comes to flaky tests. So who of you would say they have a very reliable pull request pipeline where in 99.9% of the cases, a failing pull request build means something is wrong with the code and it's not an environmental issue? Okay, so congratulations. But it's a minority, right? So, and flaky test is just one aspect of environmental issues that are causing build failures, right? So the patterns we very often see with flaky tests is that it really affects negatively the testing culture. When you have long-running tests combined with flaky tests, it basically leads to a situation that people start ignoring tests more and more. The flaky tests get skipped, might as well have not written them, right? Or they get ignored. You still merge a failing pull request build. You start speculating. Yeah, it's only that test. It's probably flaky. This thing here. Let's still merge the whole thing, right? That's because you don't want to go through another cycle, right? And that's not good, right? So basically, the whole authority of tests get undermined by flakiness. And so who of you is using the Maven or Gradle retry plugin, where you can say, if the test fails, run it again? Who else is using that? Anyone? Which is kind of dangerous. So for me, this is not a solution to the problem. It makes things more stable, but at the same time, it also creates. So if you have a pipeline where you say, we retry, and if the test fails, and the second time I run it, the build is successful, okay, but that leads to an accumulation of flaky tests. You basically, so that's why we are recommending absolutely do the retry as a detection method for flaky tests, but let the build still fail when there is flakiness, because someone has to fix it, right? It's something you have to fix, right? And then that's a big part of engineering culture. We talk with organizations saying, oh, we have all these flaky test problems, and then some developers basically say, oh, I don't have time to fix the flaky test, right? In some organization, those people would get fired, right? And in other organizations, they're having a good time, right? So that is then where you have to establish a certain culture around it, right? I'm not saying you should fire, but you know what I mean? But people have to understand this is no joke, right? It's not your personal freedom to decide not to do something about it, right? Because otherwise, you will not be able to solve that problem. But the key thing, again, use the retry plugin, use that for detecting flaky tests, and then make an organizational priority, create an issue for flaky test in your issue tracker that people really, really have to fix it. And if not, there has to be some consequences, right? Okay, so that's what I wanted to talk about today. If you are interested in learning more about the topic of developer productivity engineering, we have an early access edition of our book. We're constantly working on this. We're adding chapter after chapter. So you can go, if you just Google for developer productivity engineering, you will find that book, and then you can register and you get a free PDF of that book. Okay, more info at gradle.com if you want to. We have online workshops on that topic where you also can play with things like build cache and see if it can help you, right? Come to our booth, probably not today, right? Maybe next year at Devnexus. And yeah, that's what I wanted to talk about. Thank you very much. Any questions, right? So just, yes, please.
Is there any kind of metrics to check the health of your code based on flaky tests, or
Yes.
besides just code coverage?
Yes, there is. So there is. For example, we have a product, right, that gathers that metric and it shows you exactly. What we're doing is to assess whether a test is flaky, how bad the flakiness is. we care about how often is that test making a build fail, right? So then we show, that is for us the most important metric. How often is this test, and then we show you that, and then we show you which test method, right? And we show you then information about the environment of that test. Is it on Windows machines, on Mac machines, so that you already can reason about it, and you can then really track progress. Yes. So there is stuff. There are custom solutions out there. People build their own, right? So we have something that does that. But but before we had a product, right? We had an internal build your own solution around that. So not yet, right? At the moment we only offer that for Gradle and Maven, but CMake is on the list, Python is on the list, Webpack and NPM is on the list. It's just, it's the same problems everywhere with some variation. Yes.
We're waiting.
Thank you.